So they're saying that E is equals to 9 by x square. Then find V at x equals to 3 if V infinity is 0. So if you want to find some mass M, you have to bring it from where to where? From infinity to 0.3. That is what is our A point to B point, like that. So that's what is the question. So what is the limits? You have to take it and you have to find the V. I want to know. Let me see who will find first. Anybody out? Anybody can ask. Try first. If you try, I will make it. Okay, I'll give the even clue also. So we all knows that E is equals to what, everybody? Please respond. E is equals to what? Minus dV divided by dx. Am I right, everyone? Please respond. So now we want dV. So we have to find it V. So V means that is what dV. So dV is equals to minus E dx. Will you all agree with me, everybody? Yes, please. So if you want to find V from E, so as I said, we have to apply the concept. What is that, everybody? Integration. So integration, can you tell me the limits? We have to bring it from infinity. My point is infinity to, I have to bring it to the 0.3. So what is my limits, anybody? Let me imagine this is the A point and this is the B point. So what is my limits? Infinity to, everybody? Infinity to 3. Infinity to 3. That is what is my limits. So that's all it is. So differentiation, integration of dV is V. Limits is 3 to infinity, which is equals to integration of infinity to 3 E value. Let me take E minus outside. What is the E value, everybody? 9 minus, speak guys, 9 divided by x square into dx. So let me know, we all knows that 9 is a constant, I'm putting outside. So integration from infinity to 3, which is equals to 1 by x square into dx, which I will write as a infinity to 3 x power minus 2 into dx. Any problem? Anybody? You can ask. Are you clear, everybody?
Yes, sir.
Yes, that's all. Can you tell me what is x square? The integration of x square or x power n. What is the formula? Everybody, we all knows that. X power n formula. Integration x power n plus 1 divided by n plus 1. Am I right? Same way you can apply here. So integration of x power minus 2 is equals to, what is that? X power minus 2 plus 1 divided by minus 2 plus 1, which is equals to x power minus 1 divided by minus 1. So which is equals to, what will happen? This minus will go up, x power minus 1, which is equals to minus 1 divided by x power 1. Will you all agree with me, everybody? Am I right? Please respond.
Yes,
It equals to minus 1 by x. Is it okay, brothers? Clear, everybody? So integration, that is what V from infinity to 3, which is equals to minus 1 by x from limits infinity to 3. So now you can substitute the, if you substitute the points, what will happen? V of 3, that is what it will become, minus V of infinity, which is equals to here also, minus 1 by 3 minus of minus 1 by infinity. Of course, 1 by infinity, what will happen, everybody? And I already told you, what is the field? What is the field at infinity distance, which is equals to what, everybody? Field at infinity distance, or potential also at infinity distance. What is the potential difference at infinity distance, everybody? Infinite distance is equals to what? How much, Ra? 0. Understand? Yes. So what will happen, everybody? 0. So V of 3 is equals to minus 1 by 3. So, oh, before 9 is there, I forgot it. So minus 9. So into minus 9. So 9 ones are 9 threes are, sorry, 3 ones are 3 threes are. So minus into minus plus. So what is the answer? V of 3 is equals to, everybody? V of 3 is equals to, all of you, V of 3 is equals to 3. That is the answer. So once again, observe and solve it. So they have given E and they're asking V. So we have to apply the concept. What we can say, everybody? All of you? Integration. Okay. So E to V, always you have to apply integration. V to E, you have to apply differentiation. So please remember that. Any doubt, you can ask. Are you clear, guys?
Yes, sir.
Solid, make it quick. Any doubt you can ask me, or else we'll proceed. So this is what is the concept of potential difference, gravitational potential, and as well as gravitational field. Remember the same concepts again in 12th class. Instead of gravitational field, we'll study electric field. Instead of gravitational potential, we'll study electric potential. So exactly it will be coming, even entire concepts, just will change the terminologies and we're going to study the same thing. Okay. So till here, any doubt, anybody have, you can ask me, or else next keep heading, everyone. The concept what we are going to study is, the next one is potential, this gravitational potential due to hollow and solid sphere. So we have studied gravitational field due to hollow sphere and solid sphere. Am I right? Do you remember everybody? All of you? Yes, please. So the same thing we are going to make now. Can you hear me? Everybody. So same potential difference like gravitational field. How the potential difference for gravitational potential for hollow and solid sphere. So that is what is our next concept. So we'll learn the formulas in our today's class. Then derivations and all we'll see that. So potential due to hollow and solid sphere. Are you there, Pradosh? Hollow and solid sphere. Okay.
Yes, sir.
Suppose let me take now hollow sphere. So first, all of you refer your notebooks. Hollow sphere also we can call something. What do we used to call, everybody? Shell.
Sure.
So now let me take, if I take the hollow sphere immediately, E, gravitational field. You have written for 3 places. And can you tell me what is that? Gravitational field at 3 places. One is point outside from the center. So let me take that is R. One is on the surface. One is less than inside the surface. Am I right, everybody? Please speak, guys. Speak your points. Am I right? So having a mass M and radius R. So can you tell me what is the E? Outside, already we have taught you with the derivation. Outside, on surface, and inside. Anybody? Outside is what? R is greater than radius. Inside R is, on the surface, R is equals to R. Inside R is less than R. Do you remember this? We studied or not? Verify, please. Everybody?
Yes, sir.
Yes. So what is the E value outside for hollow sphere? Hollow sphere, what is the E value? Yes, Rudreswar? Outside, everybody. Check your notebooks and tell. I'm not asking anything new. Just what you studied, I'm asking. Minus GM divided by R square. Okay, then at the surface, R will become R. So E is equals to minus GM divided by capital R square. And inside a hollow sphere, E is equals to what? We studied. Inside a hollow sphere, E is equals to 0. But solid sphere, it is different. Solid sphere, inside radius increases, E also increases. Inside R is decreasing, E also decreasing. We have studied. Am I right, everybody? So for this one, if I take the gravitational potential, then minus GM divided by R, of course, we'll study the relations and derivations. For this one, minus GM divided by capital R. And for inside also, potential is not 0. Gravitational field is 0, but gravitational potential is no change. How, sir? Means tomorrow we'll see the derivations. Don't worry. But you see, gravitational field inside a hollow sphere is 0, but gravitational potential is not 0. So from the surface to the inside, no change. Okay, outside will change, but from the surface to the inside, everywhere the potential, gravitational potential is remains constant. Are you clear, Pradosh? Anything doubt you can ask me. Rudreswar? So that is what. Next one is solid sphere. Mr. Murali, are you writing? Rishi, Princey? So solid sphere.
Yes,
You
sir.
all know that solid sphere also. What is
Yes,
solid
sir.
sphere, everybody? Solid sphere also you have taken 3 points. What is the 3 points? Yes, please. One is outside point. Let me take X. Another one is on the surface. Let me take Y. And inside somewhere, let me take it as Z. So we all know that. So then from outside, let me take this distance is R, this also R, this also R. So then outside, can you tell me what is the E? Outside, on the surface, and next one is inside. So first, outside, can you tell me what is that, everybody? Outside. minus gm divided by r square. Both are same only, correct, guys? Here and here. Yes or no? Next, on the surface, what is happening? Minus gm divided by r square. But inside, it is not the halo, so that it will become 0. So it is not a halo. It is a solid sphere. So that you can see, if I remove even a layer by layer, if R value keep on decreases, inside alone, R is directly proportional to E. Am I right, everybody? Outside,
Yes,
R, E is inversely proportional to R square. Outside, E is inversely proportional to R square. But here you can see, inside a solid sphere, R is directly proportional to what, everyone? R is directly proportional to E. So that is what the formula will come. What is the formula we have? E G minus G into capital M into R, small r divided by R cube. Am I right, everybody? Yes, please respond. That is what.
yes, sir.
So next, what is the potential difference? That's what, gravitational potential. So for this one, same like halosphere. So that is what, minus Gm by R. And for this one also same, minus Gm by capital R, because R is equals to capital R here. And the last one is, this is the most complicated derivation. But it's very, very simple. Derivations, I'll make you as simple as possible. But your responsibility is to practice. So minus Gm divided by R cube into 3 by 2 R square minus 1 by 2 small r square. So this is the formula for inside a solid sphere. Do you understand, everybody? Inside a solid sphere, what will be there? This is what it will be. Are you clear? Please, everyone. So this is what is the E, gravitational field and gravitational potential differences, and what is the formulas and all. So remember, gravitational field of halosphere is 0, but the same gravitational field of a solid sphere is minus G into M into small r divided by R cube. Next, that is how the outside and on surface all are same. V is equals to minus Gm by R, minus Gm by capital R. Here also minus Gm by R, minus Gm by capital R. Nothing else changes. So only here inside it is 0, but here it is inside is not 0. So you have to learn this equation also. But how this equation comes, what is the approach, what is the derivation, how to derive it, that is all the things we'll discuss in our tomorrow's class. So till here you complete it, and tomorrow we'll discuss, we will plot the graphs also for solid sphere and halosphere based upon this concept. For E we have drawn the graphs or not, solid sphere and halosphere. Have you plot the graphs or not? I'm asking. Plot the graph for
Yes,
E.
sir.
Done. So same way, now we will plot the graph for V. Clear? So that we will see it in the next class. So what is the graph for solid sphere? Solid sphere, what is a graph? Halosphere, what is a graph? So that is what you have to remember. Okay, everybody. So this is what about it. Then tomorrow we'll study these derivations and as well as how they're representing graphical motion. And